It's Miss Brown speaking, and I wanted to talk to you today about evaluating algebraic expressions. I know that on Thursday, February the 6th, I gave you guys an assignment to evaluate algebraic expressions, and I looked over your assignment, and the highest score that we had was 6 correct out of 10. So that tells me as a teacher that I need to kind of step back and maybe reteach this topic. So that's what I'm doing. I want to remind you of a few things. The first thing I want to remind you of is your integer rules. So if you remember back in, I think it was maybe around October, maybe end of October, November, we started talking about how to add, subtract, multiply, and divide positive and negative numbers. So as we are evaluating these algebraic expressions, we must be sure that we are using our integer rules. So here is a reminder. So if we are adding two numbers that have like signs, and what I mean by like signs is if I'm adding a positive number plus a positive number, or if I were adding a negative number plus a negative number. Notice they have like signs. I'm supposed to add the numbers and keep the like sign. So this is what that looks like. For instance, if I'm adding positive 3 plus positive 5, I add those two numbers, 3 plus 5 is 8, and I keep the sign. So my sign is going to be positive. You don't have to put that plus in front of the 8. It's understood that it's positive. I just put it there today for emphasis. If I were adding a negative plus a negative, for instance, if I were adding a negative 3 plus a negative 5, again, I would just add those absolute values of the numbers. 3 plus 5 would be 8. And then keep that like sign. The like sign is negative, so I would be keeping that negative sign. Now, if I were adding two numbers with different signs, and when I mean different signs, I might be adding a positive plus a negative, or a negative plus a positive. Okay, so if that happens, we are supposed to first subtract the absolute values of those numbers. I don't know if you remember what absolute value is. Absolute value is a number's distance from zero, okay? So if I were on a number line and I ask you what is the absolute value of 2, notice I put 2 bars around the 2. Those 2 bars mean absolute value. All I'm asking you is how far is 2 from 0? So 2 is 2 units away from 0. I could ask you what is the absolute value of negative 2? Again, all I'm asking you is how far is negative 2 away from 0? Negative 2 on the number line is 2 units away from 0. So the absolute value of 2 is 2. The absolute value of negative 2 is also positive 2. Absolute value is never negative. Okay. So anyway, going back up to different signs, we have a positive plus a negative or a negative plus a positive. We're supposed to subtract those numbers' absolute values and keep the sign of the number with the greater absolute value. For instance, if I have 3 plus -7, notice one number is positive, one number is negative, so they have different signs. So I would actually have to subtract 7 minus 3. 7 minus 3 is 4. But I'm supposed to keep the sign of the number with the greater absolute value. So which of those numbers is farther away from 0 on the number line? 3 or -7? You would be right if you said -7 was farther away. Therefore, our answer will be negative. The answer here is -4. I could say -9 plus +10. Again, I have to, since I'm adding a negative and a positive, I have to subtract the absolute values. 10 minus 9 is 1, and I keep the sign of the number with the greater absolute value. Well, 10 is farther away from 0, so 10 has the greater absolute value, and since that 10 is positive, my answer will be positive as well. Okay, what if we're subtracting? So when we're subtracting, the first thing we are supposed to do is to, some people call it keep change, and this should really say change. Some kids call it keep change, but the actual mathematical way to say it is add the opposite. When we do that, we're going to end up with an addition problem. So all we do is follow our addition rules from there. So for instance, if I have -7 minus 3, I'm supposed to add the opposite or keep the -7 just like it is, change the subtraction to addition, and change the +3 to a -3. So I'm going to rewrite that as -7 plus -3, reflecting the fact that I'm adding the opposite or performing that keep change. Now, notice I have an addition problem where I am adding a negative number to a negative number. According to my rules, if I'm adding a negative number to a negative number, they have like signs. I'm supposed to add those numbers and keep that like sign. So 7 plus 3 is 10, and I have to keep that negative sign. So my answer would be -10. If I were doing a problem such as 8 minus 11, I would still do the same thing. I would add the opposite or keep change. So I'm keeping the 8 as it is, changing the subtraction sign to an addition sign, changing this positive 11 to a negative 11. So now I have a new problem where I am adding a positive and a negative. Since I'm adding a positive and a negative, they have different signs. So my rule is to first subtract the absolute values of those numbers, and keep the sign of the number with the greater absolute value. If I subtract 11 minus 8 is 3. And since this negative 11 is farther away from 0 than 8, my answer is going to be negative as well. So my answer is negative 3. Reviewing our multiplication and division. The rules for multiplication and division are pretty well the same, and they're up here. Notice a positive times a positive gives us a positive number. A negative times a negative gives us a positive number. A positive times a negative gives us a negative number. So if I had positive 5 times positive 4, the answer would be positive 20. If I had negative 3 times negative 2, the answer would be, remember, a negative times a negative is a positive, so the answer would be positive 6. If I had positive 8 times negative 1, remember, a positive times a negative is a negative, so my answer would be negative 8. Okay, so as we're evaluating our algebraic expressions, I need you to remember and to use your integer rules. It's very important. And then also, we're going to have to use additionally our rules for order of operations. And order of operations tells us the order in which we should solve problems. So a lot of teachers call this PEMDAS. I like to refer to it as GEMDAS. Okay? You may have heard it as PEMDAS, but you will hear me refer to it more often as GEMDAS. And that is because the first thing we need to do is look for grouping symbols. Grouping symbols can be parentheses, they could be brackets, braces. Guys, even this division line in a fraction is like a grouping symbol, because what it is doing is saying that this stuff up top is grouped together and this stuff on the bottom is grouped together. Another grouping symbol that's absent here is the absolute value symbol. The absolute value symbol just looks like two lines. I could do something like the absolute value of negative 2 plus negative 3. Remember to add a negative and a negative. They have like signs. We have to add those numbers. So 2 plus 3 is 5. And we keep the sign of both numbers. So 2 plus 3 is 5. And we have to keep the sign of both numbers, which is negative. So the absolute value of negative 2 plus negative 3 equals the absolute value of negative 5. But remember, absolute value is asking us how far is a number away from 0. The number negative 5 is 5 units away from 0. So evaluated, that would be a positive 5. What I really wanted you to know is that absolute value symbols can be grouping symbols. The next thing we're going to look for is exponents and square roots. I'm not going to say much about square roots because square roots is an 8th grade topic. So you really don't need to know much about that in the 7th grade. You should already know a little bit about exponents because exponents is a 6th grade topic. So you see on your screen 3 to the 2nd power. Remember, 3 to the 2nd power just means I'm going to take that 3 and write it down 2 times and then multiply it. So 3 times 3 is 9. So 3 to the 2nd power equals 9. Likewise, we've already studied fractions. We can also have a fraction with an exponent. So if I had 1/2 to the 3rd power, That just means I take that 1/2 and write it down 3 times. That's time 1, time 2, time 3, and then I need to multiply. So I have 1 times 1 times 1, which is equal to 1. And then I have 2 times 2, which is 4. And 4 times 2 is 8. So 1/2 to the third power would just be 1/8. Okay, after we look for those grouping symbols and exponents, the next thing we're going to do is multiply and divide. Guys, multiplication is not more important than division. Division is not more important than multiplication. So, what do we do if we encounter both of those operations in the same problem? We have to go from left to right. Whichever one is on the left is what we do first. Okay? And the last thing we're going to look for is addition and subtraction. Addition is not more important than subtraction. Subtraction is not more important than addition. So again, how do we know what to do if we encounter both of those operations in the same problem? We go from left to right. So I want to give you some examples of working this out to make sure we all understand A, how to use order of operations, B, that we are actually incorporating our integer rules as we work, and C, to let you know what I expect so far as showing work. Most of you, by the way, did a great job showing your work, but I know there are a few kids who are new to online Kataba, and I have not gotten a chance to tell those kids that it is the expectation that you show your work. So I just want to give an example to everybody to let you know what I expect. So I'm doing problem number 1 on your work for Monday. And just because I'm doing it here doesn't mean you don't have to do it, okay? You're going to do it as well. Problem number 1 says 9 plus negative 14 over n minus 6r. And we are given that n is equal to negative 7 and r is equal to negative 6. Guys, the first thing I want you to know or to be aware of, do you see this 6r right here? What does that mean? I need you to know when you have a number right beside a variable is just a letter that takes the place of a number. When you have a number right beside a variable, that indicates multiplication. So you are multiplying 6 times r. Please keep that in mind. So what we're going to do is we are going to fill in the values for the variables. So that would be 9, whoopsies. That would be 9 plus negative 14 over, and I know I keep saying over, but guys, that line means division. So it's negative 14 divided by, n is negative 7. So instead of writing n, I'm going to substitute in the value negative 7 minus 6 times, and instead of using r, I'm going to use the value negative 6. And I'm actually going to use parentheses to indicate multiplication. Okay, so now I need to evaluate this. I need to think about my order of operations. The first thing I'm going to look for is grouping symbols. Okay, grouping symbols. Now, guys, I know it looks like I have parentheses, But the only reason why I used those parentheses was to indicate multiplication. They're not really grouping anything together. They are indicating multiplication. There's nothing inside of those parentheses to do. So we technically do not have grouping symbols here, okay? The next thing we're going to look for is exponents or square roots. And if we look in our problem, there are no exponents or square roots. So the next thing we need to look for is multiplication and division. And if we look at our problem, there is both multiplication and division. So how do we know what to do? We're going to go from left to right. Now, guys, I'd like to encourage you as you are doing your problems. I need you to either get a highlighter or you could get a different color pencil and just put a box around the part or the section that you're working on. We shouldn't try to do all of this at one time. We should do this step by step. We're going from left to right. We have some division right there to complete. So we have 9 plus, and I've got to figure out what negative 14 divided by negative 7 is. Remember, a negative divided by a negative gives us a positive. So negative 14 divided by negative 7 is a positive 2. And notice everything else I am just bringing down and rewriting it until I can get to work with it. Okay, we're still talking about multiplication and division, and we still need to multiply. So we need to multiply 6 times negative 6. Okay, so I'm going to go ahead and start copying things down. I'm going to copy or just bring down 9 plus 2 minus, but I've got to figure out what 6 times negative 6 is. And here's where I've got to remember my integer rules, okay? My integer rules say that a negative times a positive is a negative. So 6 times negative 6 is negative 36. And I'm just going to put parentheses around that negative 36 to separate that subtraction and negative sign so that it doesn't look really strange. Okay, so now we're going to see if there is any more multiplication or division, and there is not. So we're going to go to the next and last step of order of operations or GEMDAS, which is addition or subtraction. And if you notice in this problem, we have both addition and subtraction. Okay, addition and subtraction. So how do we know what to do first? Remember, we have to go from left to right. So I'm going to concentrate first on 9 plus 2. Okay, and we've been doing 9 plus 2 since probably kindergarten. So 9 plus 2 is 11, correct? So notice I'm just replacing my purple box with an 11. And I'm writing everything else down, minus negative 36. Okay, so the only thing left to do is to subtract. So now I have to figure out what is 11 minus negative 36. So remember, we have to use our integer rules. We are subtracting, right? So the first thing we're supposed to do is keep change. This should say change, also known as add the opposite, okay? So I'm going to do that. I am going to keep the 11 just as it is. I'm going to change the subtraction sign to an addition sign. And I'm going to change the negative 36 to a positive 36. So now I have a positive 11 plus a positive 36. So I just follow my integer rules. I'm adding, I have a positive plus a positive. I'm going to add those numbers. 11 plus 36 is 47. And I keep the sign of both numbers, which is positive. So my answer is positive 47. So notice all the work and all the different steps that I've done to solve this problem. Also, notice I am taking time to box in or highlight the specific section that I am working on to make sure that I am actually applying order of operations. I expect to see that on your papers too. We won't do this always, but right now, just to make sure that we're paying careful attention, I need you to do your problems just as I have done. All right, so let's look at another problem. We're going to look at problem 4. Problem 4 says the opposite of negative 20 divided by n minus 8 minus 2k, where n is equal to negative 5 and k is equal to negative 3. So the first thing we're going to do is to rewrite that and substitute in the specific values. I'm actually going to change my pen color here. Okay, so we're going to say the opposite of negative 20 over n is equal to negative 5 minus 8 minus, remember that 2 beside the k means 2 multiplied by k. So that would be 2 times, and I'm going to use parentheses to indicate multiplication, 2 times negative 3. Guys, you don't have to use parentheses. Remember, when we're indicating multiplication, you could just use the cross, or you could use a dot, or you can use parentheses, okay? I prefer, for this particular problem, parentheses, but you do what you understand best. Okay, so now that we have substituted in the numbers for the variables, now we need to start examining our order of operations. The first thing we're going to look for is grouping symbols inside of which there is something to do. And I know it looks like we have parentheses, but those parentheses in my problem stand for multiplication. There's nothing on the inside of those parentheses to do. So we don't have grouping symbols, okay? Then we're going to look for exponents and square roots. And in this particular problem, we do not have exponents and square roots. So the next thing we need to do is look for multiplication or division. And we do have both multiplication and division. So we need to go from left to right. So the first thing we are going to look at is this negative 20 divided by negative 5. Okay, so remember our integer rules. Oopsies. For division. Okay, it says a negative divided by a negative gives us a positive. So therefore, negative 20 divided by negative 5 gives us a positive 4. So guys, notice there is a little negative sign in front of the box. Don't forget to write that negative sign down. And then we said the stuff on the inside of my box is equal to a positive 4. So I'm writing down a positive 4. I'm bringing down the minus 8, bringing down the minus 2 times negative 3. Okay, so we're still on multiplication and division. So we still have some multiplication. And to make things a little bit easier, usually I just looked at 2 times negative 3. I can actually consider this a negative 2 times negative 3. So I'm going to do that, okay? Negative 2 times negative 3. Again, a negative times a negative gives us a positive. So I'm going to replace that box with a positive number, all right? So here I go. I'm going to copy down the negative 4. I'm going to copy down the negative 8. Guys, negative 2 times negative 3 is a positive 6. And because of the way I did this problem, I am going to have to include that positive in front, positive 6. That positive sign is also acting as my operator. Guys, there's very little difference between a plus sign and a positive sign. Okay? So, what you're going to start hearing me do, especially over the next, let's say, 2 to 3 weeks, 1 minute I'll call that sign a plus sign, and the next minute I'll call the same sign a positive sign. And that's because mathematically there's very little difference. Okay, so we've done all our multiplication and division. So the only thing we have to look for is addition and subtraction. And there is addition and subtraction. So we're going to have to go from left to right. So the first thing that I need to look at is negative 4 minus negative 8. So we're going to have to use our integer rules. If we are going to subtract, remember the rule is to keep, change, also called add the opposite. So I need to do that. I need to keep the negative 4 just as it is. I need to change that subtraction sign to an addition sign. I need to change that positive 8 to a negative 8. So now I have negative 4 plus negative 8. So I'm going to now use my addition rules. I'm adding a negative plus a negative so they have the same sign. All right. My rule is to add the numbers and then I keep that sign of both. So 4 plus 8 is 12. And since they are both negative, my answer is negative 12. So I'm just replacing my box with a negative 12. And then I'm bringing down everything else on the outside of the box, which is a positive 6. Okay, so there is only one thing left to do, and that is negative 12 plus a positive 6. So again, we have to remember to use our integer rules. We are adding, but they have different signs. One is negative, one is positive. Remember, we have to subtract their absolute values and keep the sign of the number with the greater absolute value. So 12 minus 6 is 6. And negative 12 is a farther distance away and has a greater absolute value than that positive 6. So therefore, my answer is going to be negative. And negative 6 is my answer. Let's look at another problem. So I am now looking at problem number 7. Problem number 7 says 5 times negative 4r minus 8d. And we have r is equal to 5 and d is equal to 7. So the first thing I'm going to do is substitute in the value for the variables. So that would be 5 minus, and that negative 4 beside the r indicates multiplication. So it's minus negative 4 times, and r is 5, minus 8 times, and d is 7. Okay, so now we need to start using order of operations. The first thing we're looking for is grouping symbols inside of which there is something to do. And we do have parentheses, so we need to look inside the parentheses and figure out what needs to be done. Okay, so if we look inside the parentheses, there are 2 instances of multiplication and 1 instance of subtraction. According to our order of operation rules, multiplication comes before subtraction, so we need to multiply. And since there are 2, we're going to have to go from left to right. So the first thing we're going to do is negative 4 times positive 5. And if we go up to our integer rules, remember when we are multiplying a negative times a positive, our answer is going to be negative. So I'm going to recopy things. I'm going to write down 5 in the parentheses, and then I'm going to replace that box, negative 4 times negative 5, with a negative 20. And then I'm just bringing everything else down. Okay, so I'm still doing my grouping symbols, and I still have some multiplication inside my grouping symbols to do. So I am going to look at this 8 times 7. So notice 8 times 7, both that 8 is positive and that 7 is positive, and a positive times a positive gives us a positive number. So I'm going to replace my box with a positive number. So I'm recopying the 5 times negative 20 minus, and again, my box, positive 8 times positive 7 is a positive 56. Alrighty, so I'm still on my grouping symbols, and the only thing left to do on the inside of my grouping symbols is to subtract. But I must make sure I am using my integer rules. So remember, when I subtract, I am supposed to keep, change, change, okay? Also known as add the opposite. The better way to say it is actually add the opposite, but my kids understand keep, change, change a little more. So that's why I'm going to keep that negative 20 as it is. I'm going to change that subtraction sign to an addition sign. And I am going to change that positive 56 to a negative 56. So now on the inside of my box, I have negative 20 plus negative 56. So I am going to follow to my addition rules, and I am adding a negative and a negative so they have the same sign. So all I have to do is add those numbers and take that like sign. So I'm going to recopy things down, 5. I still need those parentheses. And then a negative 20 plus a negative 56 gives me a negative 76. The reason why I needed to keep those parentheses, even though there's nothing inside the parentheses to do, the parentheses indicate multiplication, and that's why I still need them. Okay, there's only one thing left to do, and that is 5 times negative 76. Again, we've got to use our rules, and our rules tell us a positive times a negative is a negative. So our answer is negative. And then we've got to figure out what 5 times 76 is. 5 times 70 is 350. 5 times 6 is 30. 350 plus 30 is 380. So I believe that's correct, but it's a little late and I better check my math because teachers make mistakes too. All righty. That is 35. Yeah, that's it. Okay, one more problem, guys, and then you're on your own, okay? So the last problem that I'm going to do is problem number 5. So problem number 5 says -6 times -9n Uh-oh, guys, I've lost track. Hold on. I don't know. -6 times -9n plus 2c. If I've already done this problem, please excuse me. Again, it's late and I'm a little tired and I don't think I've done it, but I don't know. Anyway, so here we go. We are going to plug in the values for the variables. So that's -6 times -9 times 7 plus 2 times -5. Okay, so following order of operations. The first thing we're looking for is grouping symbols, which we have. And we need to look inside the grouping symbols and decide what to do first. So notice there are 2 instances of multiplication and 1 instance of addition. Multiplication becomes before addition. And since we have 2 instances of multiplication, we need to go from left to right. So the first thing we're going to do is multiply -9 times 7. Alrighty, so we have a negative times a positive, which is a negative. Okay, so I'm going to replace my box with a negative number. So that would be -6 times, replacing my box with a -63 plus 2 times -5. Okay, still looking at my grouping symbols, I still need to multiply this 2 times -5. And remembering my integer rules, a positive times a negative is a negative. So I'm going to have to replace my box with a negative number. I'm going to go ahead and copy everything down. -6 times -63 plus +2 times -5 is a -10. Okay, still doing parentheses. So inside of my parentheses, I need to add. And I am adding a positive and a negative number. Oops, I said that incorrectly, guys. They're actually a negative and a negative. So I'm going to add those numbers and keep the sign of both. So I have -6 times Negative 63 plus negative 10. 63 plus 10 is 73. And then I need to keep that negative sign of both numbers. Okay, now the only thing left to do is this multiplication of negative 6 times negative 73. So remember, we have a negative times a negative gives us a positive. So our answer is going to be positive. We just have to figure out what 6 times 73 is. So let's do that off to the side. 3 times 6 is 18. Write down the 8, carry the 1. 7 times 6 is 42, plus 1 is 43. So our answer is a positive 438. All right, guys, have a great day. Bye-bye.